Hello, my name is Ramazan ERDEM, Associate Professor Doctor from Akdeniz University. My specialty and subject is textiles, technical textiles, and nanotechnology applications for textile materials. And today I am going to talk about sustainable fashion and green textile design. The fashion industry produces the world's 10% of carbon dioxide emissions. Meanwhile, the textile industry generates a large number of greenhouse gases due to the energy it uses for the production, manufacturing, and transport process of millions of garments. In the other respects, falling clothing prices and overproduction of clothing allowed people to buy more clothing, resulting in more textile waste. A family in Europe throws nearly 30 kilograms of clothes every year. Only 15% is recycled or donated. The rest directly goes to landfill or is incinerated. There is more than $5 billion worth of textile waste every year, which comes from disposed of materials, underused garments, and an absence of appropriate reusing measures. Although natural materials like cotton, hemp, jute, etc. are considered sustainable, the production of those materials requires a large amount of cultivation, land, and water. For instance, to produce just one cotton shirt requires approximately 2,700 liters of water. Most consumers believe that the use of natural textiles protects the environment. However, different sources provide the opposite facts and prove that manufacturing natural fiber like cotton is extremely pollutant. The production of synthetic fibers relies on non-renewable resources, and their extraction process involves the usage of high-energy machinery. The most commonly used synthetic material in the fashion industry is polyester, and manufacturing requires intensive heating and a large quantity of water for the cooling process. Besides harming animals, the leather industry is responsible for 15% of human-induced greenhouse gas emissions and uses a large quantity of water and chemicals in the tanning process. Sustainable fashion is part of the slow fashion movement, developed over the past decades and used interchangeably with eco, green, and ethical fashion. Ethical fashion is associated with fair working conditions, a sustainable business model, organic and environmentally friendly materials, certifications, and traceability. The slow fashion movement and sustainable fashion are increasing in importance, yet consumer awareness remains low. Slow fashion and more specifically sustainable fashion seek to empower workers throughout the supply chain, utilize upcycling, recycling, and traditional production techniques, and incorporating renewable and organic raw materials. Sustainable fashion is predominantly associated with environmental sustainability, such as the use of renewable and eco-friendly raw materials, the reduction of the carbon footprint, durability, and longevity. Slow fashion is associated with quality rather than quantity. What is circular fashion? The concept of circular fashion is based on the main principles of circular economy and sustainable development. Circular fashion concerns the entire life cycle of a product, from design and sourcing to production, transportation, storage, marketing, and sale, as well as the user phase and the product's end of life. In a circular model, products are designed and developed with the next use in mind. Less than 1% of clothing is recycled into new clothing. Green Strategy offers 16 key principles to support and promote a more circular and sustainable fashion, apparel, and textile industry. These are design with a purpose, design for longevity, design for resource efficiency, design for biodegradability, design for recyclability, source and produce locally, source and produce without toxicity, source and produce with efficiency, source and produce with renewables, source and produce with good ethics, provide services to support longer life, reuse, recycle, or compost all remains, collaborate well and widely. In the consumer side, use, wash, and repair with care, consider loan, rent, swap, or redesign instead of buying new, buy quality as opposed to quantity. If we just define the difference between the biomaterials, bio-based, biofabricated, biosynthetics, let's look at this slide. Bio-based materials are wholly or partly derived from biomass, such as plants, trees, or animals. Example of bio-based materials would include, but not are limited to, natural fibers, for example, cotton, wool, and silk, man-made cellulosics, for example, viscose, natural polymers, for instance, chitin, keratin, and casein, and other animal leathers. Biofabricated materials are produced by living cells and microorganisms such as bacteria, yeast, and mycelium. Examples of biofabricated materials would include fermented biosynthetic, biofabricated ingredients, and bioassembled materials. Biosynthetics are synthetic polymer materials comprised in whole or in part of bio-derived compounds. These compounds can either be made with an input of biological origin, like biomass, and or where the process is performed by a living microorganism. Examples of biosynthetics would include the fermentation of sugars, etc., or the catalytic conversion of biomass to create precursor chemicals for synthetic polymers such as nylons, polyesters, and polyurethanes. Biofabricated ingredients are building blocks produced by living cells and microorganisms, for instance, complex proteins like silk or collagen. Examples would include fermented recombinant silk, which then has to be spun into a fiber or processed to form a sheet material. A bioassembled material is microscale structure that has been grown directly by living microorganisms such as mycelium or bacteria. Examples would include mycelium or microbial cellulose leather alternatives. Biofabrication. Discoveries of various materials and manufacturing processes have enabled the development of new fabrics and consequently a textile revolution. Wearable biotechnology produced by researchers in the areas of design, fashion, biology, and engineering featured to the textile market new possibilities of fabrics and surfaces, seeking ecologically correct and sustainable solutions. In this field, some important brands can be introduced, such as Open Biofabrics, Pili, Scobitech, Laura Lachman, Atelier Symbiosis, Caroline Raff Studios, and etc. If we look at the Pili France example, the company's technology is based on microbial enzymes re-engineered to produce brilliant and effective dyes from renewable resources. Enzymatic synthesis allows to be partners with microbes to create materials in sustainable ways, saving energy and reducing waste. Enzymes can do chemistry with remarkable precision and without large inputs of energy or toxic reagents. At Pili, new dye technology is being developed by designing enzymatic cascades that turn renewable carbon feedstocks such as sugar into textile dyes. The dyes are obtained by integrating the genes for each enzyme into bacteria or other microorganisms. We call them the cell factories. These bacteria are grown in water-based bioreactors using sugar as their main food source. This process requires no fossil fuels and no toxic inputs and produces no harmful byproducts. Microorganisms are grown with renewable nutrients. At the end of a day, billions of microorganisms are produced. The technology can be scaled up for high production, lowering costs without sacrificing quality. At the end of the fermentation process, the final pigments are separated by simple filtration. Because pigment molecules are so small relative to the size of bacteria, the products are compatible with current dye infrastructure and processes and offer a revolutionary sustainable fashion. If we look at the example of Scobitech from Germany, Scobitech is an awarded German startup exploring sustainable and vegan materials for textile and automotive industry to replace animal and or fossil-based polymers. Natural action shoe. From fitting barefoot shoe made from bacterial cellulose equipped with controller hardware to explore VR or AR environments and facilitate a hands-free experience. Tailored form-fitting glove, if you look at, entirely made from bacterial cellulose, made from semi-processed kombucha leather. Due to hydrophilic properties of the material, the glove provides reliable, accurate screen taps on touch devices. If you look at the fourth example, interactive tree costume made from bacterial cellulose, equipped with 8 meters of LED, controlled by a microcontroller. Another example is biker vest, which is called also Maximum Fungi, is a fully functional and tailored biker vest equipped with RGB LEDs and glass fibers controlled by 2 microcontrollers. Laura Lokman from the KUKA, the Netherlands. In Sematics research, the possibilities of growing bacteria in patterns were explored by exposing them to sound frequencies. The resonance of sound frequencies is known to create geometric patterns in matter. In solid matter, these patterns are called Chladni figures, and in liquid, they are named Faraday waves. The results showed textiles that were dyed in an even and all-over way with higher saturation than textiles. Being Biogenic Inc. is a partner between Living Color and VTL, Vienna Textile Laboratory. The Being partnership aims to create biogenic inks for textile printing, providing a competitive alternative to polluting colored petrochemicals. This project has been funded by EU's program for the competitiveness of enterprises and SMEs. Moving Color is a collaboration with SKUA Studio. This shoe collection brings together innovation, design, and craft. With dye made from bacteria, the leather and heels of the shoes have been processed. Unlike many toxic dyes, this dye is much cleaner and less harmful to the environment. In addition, the bacteria dye adheres to almost any surface, making it well suited for use within various design disciplines. Milo is a sustainable leather alternative made from mycelium, the root-like system of mushrooms, and it is produced in the premises of Bold Threads, which is located in the United States. The process begins with mycelium cells grown on a bed of renewable organic substrate inside a vertical farming facility that is powered by 100% renewable electricity. Billions of cells form a densely interconnected network of soft foam that is harvested to make Milo. The remaining substrate is composted. Guided by green chemistry principles, the harvested mycelium is processed and transformed into sheets of soft biomaterial. Surface texture and finishing is applied by a leather working group, gold-rated tannery for an unmistakable resemblance to traditional leather. Microsilk is another product from both threads. Spiders produce silk fibers with remarkable properties, including high tensile strength, elasticity, durability, and softness. The technology has been developed to sustainably replicate this amazing process at a large scale. Another example is from Roya Agigi. Biogarmentry is a transdisciplinary collaboration of nature, science, and design in which living organisms become an essential part of the design process. Researchers of University of British Columbia created the first proof of concept for the survival of photosynthetic living cells on natural textiles, such as different kinds of cellulose and protein-based fibers. For developing the living fabric, a mixture of cells were spun into natural fibers. The outcome of this experiment was the first non-woven living and photosynthesizing textile. This textile is 100% natural and biodegradable, fully compostable, and more importantly, the material will work while living to purify the air through photosynthesis. The biogarmentry family consists of 6 textiles that come from different plant sources and absorb different gases from air. Each piece of biogarment, alive and healthy, requires users' attention and time. Bacterial cellulose, which produce vegan leather. Cellulose is an important natural material used in the textile and clothing industry and is one of the most abundant polymers or biopolymers on Earth. It is harvested from plants. Plant cellulose is produced in large quantities, thus causing a significant reduction in forest and land resources. On the other hand, bacterial cellulose, an alternative extracellular biomaterial, has the same chemical formula as plant cellulose, but it has a purer structure than plant cellulose because it does not contain hemicellulose, pectin, lignin, and other impurities. Moreover, the diameter of vegetable cellulose fibers is approximately 13 to 22 micrometers, and its crystallinity varies between 44% and 65%. In contrast, bacterial cellulose fibers are nanometric in nature, with diameters ranging from 10 to 100 nanometers and crystallinity close to 90%. Bacterial cellulose is produced extracellularly by many species of gram-negative bacteria belonging to the genera Acetobacter. In recent years, bacterial cellulose has inspired fashion design projects and attracted the attention of the fashion and textile industry within the scope of sustainability. It is an environmentally friendly, renewable, and organic raw material that is safe in contact with the human body. It has unique properties such as a high degree of crystallinity, tensile strength, thermal stability, biodegradability, elasticity, and porosity. One way to obtain bacterial cellulose is to produce kombucha, which is a probiotic beverage, through fermentation by adding teas of the Camellia sinensis family as a carbon source for fermentation and a sweetener as a nitrogen source for fermentation again, to culture based on the symbiosis of bacteria and yeasts. Through this fermentation process, a membrane called SCOBY, which is symbiotic culture of bacteria and yeast, is formed. Acetic acid bacteria in SCOBY play a role in converting ethanol produced by fermentation into acetic acid. Culture-dependent RNA sequence analysis showed that between 86 and 99% of the Gluconobacter was present in the symbiotic culture. This bacterium is responsible for the production of cellulose biofilm. The yeast community metabolizes these sources in the environment into glucose and fructose and produces ethanol from glucose. The acetic acid acts as a stimulant for the yeast to produce more ethanol, which is then converted into acetic acid by the bacteria. This process causes the accumulation of ethanol and acetic acid in the medium and acts as an antimicrobial agent, preventing contamination by pathogenic microbes. Bacterial cells are also stimulated by vitamins and other nutrients released as a result of the death and autolysis of yeast cells. Bacterial cellulose can be produced by static or agitated cultivation methods. In agitated cultivation, small bacterial cellulose particles or pellets are produced with lower degree of polymerization, crystallinity, and mechanical strength compared to cellulose produced in static fermentation. One of the reasons why the agitated cultivation technique is not preferred for kombucha cellulose production is that it exhibits disadvantages such as high turbulence and shear stress, which can cause mutations in cells and make them cellulose negative. In static cultivation, cellulose is formed on the surface of the culture medium within a fixed container in static cultivation. As the fermentation time increases, the thickness of the cellulose membrane increases, and this continues until the cells trapped within the membrane become inactive or die due to lack of oxygen. The presence of hydroxyl groups on the surface of the membrane allows modification of cellulose pellicle with chemicals. For this reason, many additives can be added to cellulose to improve its physical, chemical, and mechanical properties. In the production of bacterial cellulose from kombucha, the type of tea used, for example, green tea, black tea, oolong tea, etc., the type of sugar used, again, glucose or sucrose, and some additives affect the efficiency of the process. Additionally, operational factors such as temperature, pH, surface area of the reactor, and fermentation time also have critical effects on the formation of the cellulose membrane. In the study of Kaminski et al., 8 grams of black tea was brewed in less than 1 liter of boiling water for 5 minutes. And they can produce the bacterial cellulose like you see on the slide. There is another scientific experiments. I would also like to some commercial materials in the market related to bacterial cellulose. One of the favorite one is BioCouture. Susan Lee is the founder and CEO of Biofabricate, a platform nurturing collaboration for design and biology to grow the future of sustainable materials for consumer products. Lee's groundbreaking book, Fashioning the Future, Tomorrow's Wardrobe, was the first to articulate the future of fashion through science and technology. Lee showed the wearable features, audience a range of jackets and shoes made from biomaterials produced by bacteria in a vat of liquid to produce bacterial cellulose, a material that has similar properties to leather. You can see the examples of these products at the bottom of the slide. So, if you talk about the sustainable materials that are revolutionizing the fashion industry, interestingly, we can also use the apple leather. It is a bio-based material made using apple byproducts from the juice industry. When apples are pressed to create juice, apple pomace and peels are left that contain a lot of cellulose content, which is great for producing new fabrics. To do so, apple pomace is reduced to a powder, and once it has been processed, it is combined with a synthetic material polyurethane. The final result is what we call apple leather. Apple leather is soft and durable and has a much lower environmental footprint compared to cowhide leather. It is often used to produce shoes and small accessories like wallets or handbags. Allegro, Oliver Company, Vera and Samara are a few brands using apple leather to design beautiful, sustainable products. Leaf leather is another option, which is a plant-based leather alternative made from tree leaves, generally teak leaves. It is strong and water resistant, and the leather features the natural design of leaves, making it unique and beautiful. To produce leaf leather, fallen teak leaves are collected and no trees are harmed to do so. The leaves are soaked in water, dyed, and laid flat together to dry. The drying process bonds them, which leaves us with a large sheet of leaf material that is then mended with cotton fabric. Before it can be sewn into accessories, a thin BOPP film is applied to make the fabric waterproof and more durable. Tree Tribe and Junglee both create cool wallets, bags, and journals out of leaf leather. Veggie, it is also known as wine leather, is a fabric made from leftover grape skins from winemaking, vegetable oils, as well as other natural fibers from the agro industry. It is estimated that for every 10 liters of wine produced, 2.5 liters of waste are generated or created. This waste can be upcycled into 1 square meter of wine leather. To produce veggie, the grape mark, which consists of grape skins, stalks, and seeds, has first to be dried. After this step, it is combined with vegetable oil and water-based polyurethane. The mix creates a bio-based material that is coated into fabric. The production process excludes toxic chemicals, dangerous solvents, and heavy metals. Some great brands that use veggie are Ghani and Pangea. Pinatex leather is an innovative natural textile made from pineapple leaf fiber, which is an agricultural waste product. When pineapples are harvested, their leaves are collected and the long fibers are extracted with special machines. After they are washed, the fibers are dried and they go through a purification process to eliminate impurities. The fluff-like pineapple leaf fiber that is left is mixed with a corn-based polylactic acid and transformed into a non-woven mesh called pinale felt. Finally, the pina felt is colored using certified pigments and coated with a resin made from polyurethane to make it even more durable and waterproof. Pinatex has been used by over 1,000 brands, including Swala and No Saints. Nettle fibers. Over the centuries, the use of nettle fibers to make clothes was very popular, but it quickly declined when we started using cotton as an alternative, which was easier and more convenient to grow. However, clothes made from nettle fibers are more sustainable than those made of cotton, because nettles need less water and pesticides to grow. Nettle fibers are extracted from the nettle plant stem and are then carded and spun. This process creates a strong cord that can be used to produce ropes and finishing nets, or when blended with cotton or wool, to create clothing. Pangea has an entire denim collection made from white Himalayan nettle. Orange fiber. 110 to 120 million tons of citrus waste are generated around the world. An Italian company, Orange Fiber, decided to do something about it and created a sustainable fabric made from orange juice byproducts. To produce orange fiber, the company uses hundreds of thousands of tons of orange waste. It extracts the cellulose from the peels using its patented process and turns it into a fiber that is spun into yarn. Then it is woven into a silk-like fabric that is soft and lightweight. It can also be shiny or opaque depending on the final use. Italian luxury brand Salvatore Ferragamo launched in 2017 a capsule collection of women's wear made from citrus byproducts in collaboration with Orange Fiber. Cactus leather. Cacti are amazing plants. They regenerate the soil naturally, help prevent soil erosion and desertification, and they can absorb carbon dioxide up to 30% of their body mass. But they can also be turned into sustainable fabrics. Developed in Mexico, cactus leather is made from Opuntia cactus, also called nopal. Only the mature leaves of cacti are harvested, meaning that no cacti are harmed in the process. Cacti also need very little water to grow, and there is no need for artificial irrigation or pesticides. After the leaves are cut, they are meshed and dried for a few days. They are then mixed with non-toxic chemicals. More and more brands are designing products with cactus leather, including Allegria, Miomojo, and Keva. Biofabricated leather created by the company Modern Meadow. Modern Meadow makes it one-of-a-kind lab-grown material from collagen. More specifically, it grows a strain of yeast that produces collagen, which is a protein we can find in the skin. The collagen is then purified, pressed into sheets and tanned, all without using animal products or toxic chemicals. The final material is very similar to co-white leather, but it is stronger, thinner, lighter, more versatile, and sustainable. Lotus fabric made from the lotus flower looks like a blend of silk and linen, and it is breathable and wrinkle resistant, which makes it ideal for clothes and accessories. It is also soft to the touch, stain resistant, and 100% waterproof. The production process of lotus fabric is inspired by ancient techniques. It is sustainable and very time consuming since it is done by hand. Once the stems of the lotus flowers are harvested, workers delicately extract the microfibers from the stems by hand. The fibers are then dried and they are carefully rolled into a thread that will be used to weave clothing. You can find beautiful clothes and accessories made from lotus flowers and jungly and lotus paradise. Spinova fabric, Finnish company Spinova created a sustainable fiber made from wool, agricultural waste, textile waste by observing how spiders spin their webs. The production process of Spinova fabric uses 99% less water than cotton production, generates minimal emissions, and does not involve toxic chemicals. To produce this fabric, the company starts by refining cellulose made of FCC certified wood. The pulp then flows through a nozzle at high pressure, where the fibers rotate and align with the flow. After that, the fibers are dried and collected before being spun into yarn. The resulting fabric is 100% biodegradable and recyclable, which means that it is made in a closed-loop system. The North Face, Bergans, and Marimekko partnered with Spinova to launch their own collections made of Spinova fabric. Banana fiber is taken from the Poseido stem of a banana plant. Banana fiber can be removed from the Poseido stem through several different processes, manually or through retting. The machine process allows for better quality fibers to be obtained from the Poseido stem and produce up to 20 kg a day per machine. A machine which has rotating parts with blades attached is commonly used. Pieces of the Poseido stem are fed. Pieces of the Poseido stem are fed through the machine and come out crushed and pulpy. They are then degummed, washed, and dried. Retting is a process often used on bast fibers to remove non-cellulosic material attached to the fibers to release individual fibers. There are 5 different kinds of retting. The Poseido stem has several different qualities of fiber due to the layers that are formed in the stem. The outer layers produce a coarse fiber, the middle layers produce a shiny and soft fiber, while the inner layers have an even softer fiber. Econil. Cacti are amazing plants. They regenerate the soil naturally, help prevent soil erosion, the desertification, and they can absorb carbon. Finishing nets have been made from nylon for more than 50 years now, and they are the biggest source of large plastic pollution in the oceans. Thankfully, the brand Aquafil found a way to upcycle and reuse abandoned finishing nets. It created Econil, a sustainable fabric made of recycled nylon yarn from fishing nets, textile production scraps, and other synthetic waste. Thanks to a regeneration and purification process, the nylon is recycled back to its original purity. It is then processed into yarns and other polymers. The final material Econil can be recycled infinitely without losing its quality. Producing Econil lowers the global warming impact of nylon by up to 90% compared to making conventional nylon. Patagonia, Stella McCartney, Girlfriend Collective, and Peony all have products made from Econil. Alg-based textiles. Over the past few years, different companies like Alg have been revolutionizing the fashion industry by developing fabrics and dyes made from alg. Alg works with another company, Algatech, which grows alg using vertical farming, meaning that alg are grown indoors in vertical stacks using solar energy and seawater. Alg is then able to convert alg into a liquid that can be used as a textile dye. By adding cellulose to the liquid, the company is also able to create fibers for the textile industry. The production process is energy efficient and free of hazardous chemicals. Also 80% less water is needed to produce alg-based fibers compared to the production of cotton. A few brands using alg in their products are Hilo Athletics, Dr. School Shoes, and Pangaea. Lyocell, or another name is Tencel, is a type of rayon that has been gaining popularity in recent years as more and more brands have been making clothing from it. There are different kinds of lyocell, the most famous one being Tencel. Tencel is made from eucalyptus trees sourced from sustainably managed forests. The fibers are harvested, pulped, and mixed with a solvent before being dried using a process called spinning. The mixture is pushed through small holes to create threads. It is chemically treated and the fibers are then spun into yarn. Tencel is made in a closed loop system in which water and solvents are recycled. Tamga Design, Saint Basics, Amorvert are some of the companies produces the products with Tencel. Thank you for your attention.